Well, a very good welcome to all of us, all 7 of us. And I'm going to share my screen and start a talk, which will take about 15 to 20 minutes, and then we can have a discussion and questions. People still arriving. Robot factories in space. Well, of course, the key technology is robotics, and I shall spend a few minutes on that because the question is, you can make robots in space, but robots are needed to make robots in space. If we look at previous examples of robots, I'm sharing my screen. I should go straight to the next. Yes. I went too fast there. This is, of course, 2001. Probably we all saw that. I'm going to mute everyone before I go any further. That means I've got to go back to. No, well, I've missed that. I should have muted everyone. I expect everyone saw 2001. I can't believe that this wheel that we see in space can't possibly have thought it could be completed by 2001. So we're looking at the far future. Looking at it, it seems to me that it's half built. It's still being occupied. Of course, it's turning slowly in order to create artificial gravity, but there are no astronauts hovering anywhere around, and therefore it's being built presumably by robots. And the idea of robots has been around for a long time. As we saw earlier, in fact, the 17th century saw probably one of the first robots, the golem. Adam, the birth of all human beings, was, of course, a golem to start with. But this particular golem was programmed by putting instructions into the slot in his belly, which you can see there. But it's a very old model, and it's obviously obsolete. In the 20th century, the idea really caught on. And you can see the left-hand side, but there is a radio control car controlling these automated police people, robots. That's 1924. The right-hand side, the design is one that I recognize from the 1950s. 1 6 bought me a copy of Astounding Science Fiction, and this was very much the style of Astounding Science Fiction. What that robot is saying possibly is, what do I do with this? I don't think there's a polite answer. Let's move on to real robots. The 21st century produced this. It was an adaptation of Isaac Asimov's novel, I, Robot. And for the first time, we recognize that robots can go amiss and they can behave in a way that they should not, but where they get their instructions from is not clear, because most of these humanoid robots, of course, do what they're told. And actually, real robots of the sort that we now have in 2023 look much more like these 3 things in the front. They are semi-autonomous robots. That is to say, they have sufficient intelligence to run, to jump, to wriggle through barbed wire and do all sorts of wonderful things, but they are controlled. Their aim comes from the 3 humans that stand behind them, who you can see have got little laptops in order to control their particular robot. And that's another example is just a few miles from me. Oh God, I won't take that call. And although there are half a dozen or a dozen robots, they are being controlled by another robot. So the idea of the autonomous robot has not yet arrived. Another example are the 5 robots that we see on Mars, which are controlled from Earth. There are 5 of them, with the most primitive from 1997 not being very useful now, but the other 2, Spirit and Opportunity, have been useful, and they are programmed by the Jet Propulsion Laboratory in California. It takes about 20 minutes for instructions to read them, so they are semi-autonomous in the sense that they can decide how they get to the point that they have been pointed to. They are under the control of NASA, and NASA, of course, is responsible for policy, robot policy and space policy, but it is in effect a commissioning agent. It doesn't do anything itself, it commissions organizations and people and corporations now, because as of April 2022, last year, this new Fiat began, and sorry, there are people arriving late. And this has changed the direction completely of the strategy. It says quite specifically in space servicing, assembly and manufacturing, and therefore there will be some manufacturing conducted in space. It is believed in the future, and the technologies to make that happen are already beginning to take shape. It could be said, of course, that Falcon 9 rockets, these are just boosters, are in effect robots, because 1 minute before they take off, they take a command of their instructions, and thereafter, until they land, they program themselves. They can be diverted, they can be blown up, many things can be done, but generally speaking, they are successfully semi-autonomous robots. A new arrival is Axiomspace, and these are people worth watching. You can see the people that they're working with, including NASA and Airbus, and all sorts of very important and very rich corporations. So they are quite serious about their attempts. They will, in fact, be making the first commercial substitute for the International Space Station, which is likely to disappear in about 10 to 15 years. Axiomspace are fairly significant in terms of their plans. This is what they intend to build in space. Very ambitious, but they seem to have the money and the technology to be able to do it. Here, they have already put 2 groups in space to the International Space Station. One of them, second from the right, is Peggy Whitson. I was delighted to see her. She was the chief astronaut of NASA. She's 63 years old, and she now works for Axiomspace. So at 63, she is in effect one of us. The 2 outside people are from Saudi Arabia, and that means that Saudis are being decided to put quite a lot of money into this sort of venture, which is very interesting. There are other companies with many plans. Here is a plan from a company originally just involved in creating rockets, but now they have decided to look at the idea of creating habitats in space. This particular habitat that you see is about half a mile across. It's not started yet, but I think we can assume that they are working on it and they have the technologies. One of the other technologies that will be required, and this is some research being done by VAST, is how to create artificial gravity if you can't make a giant wheel. So this is an experiment that they intend to conduct into artificial gravity. Where they get the material from for their creation, for the robots to make things, it would be foolish, of course, for humans to go prospecting. They are too vulnerable, they are too soft, they require a great deal of energy, and they're really not suitable. And most of the work, we assume, certainly for mining the asteroids and therefore mining the materials that robots will use to make these habitats, will not be done by humans but by robots. The Chinese certainly believe that, and in fact China Aerospace have already, I believe this is actually a device, it's not just an artistic representation, it's an actual one. Very interesting that China is following on. Now, the materials that we now believe might be mined from the asteroids would be dragged back to Earth, according to this representation. This I severely doubt. There'll be no point in dragging it. The most dangerous part of the journey into space is the journey in and the journey out. So why not, if you've got it on an asteroid, why not make it on an asteroid? So yeah, that is what I think will be the future. Made in Space is a very good sort of rallying cry, but it's also the name of a company called Made in Space. And they are taking part with the Space Studies Institute, and a lot of these companies are working on various aspects of the technologies needed to create habitats. The Russians tried welding very early on, and they were disappointed in the results, but the American results were much more interesting. Welding in space is actually quite possible, but it's very, very different. You don't need so much heat in order to weld rods together, but if something very interesting happened, if you take a rod in space and cut it in half, you can rejoin it by pushing the ends together quite hard, and it becomes a single rod again. And that is because there is no oxidation on the ends of the rod. And therefore, you don't even need any sort of arc welding in order to join rods in space. I suspect that that's going to be extremely useful. Moving on, the company Made in Space actually use a technology called WAAM, WAAM, which stands for Wire Arc Additive Manufacture, using a wire or a fairly thick wire in order to create objects. It's 3D printing, but in a different sort of form. You can see a 3D printer making an object here. If we move on, if we use rods and wire in order to manufacture, then MX3D, Made in Space, have conducted some very useful experiments. You will see, for example, one of their designs is for a bridge across a canal in Amsterdam, and they actually conducted some tests there, and there you see the test bridge that they made in their own manufacture. So we can manufacture using robots. Here is the final result, the bridge being opened by Queen Juliana of the Netherlands, and that was 2 years ago. So wire additive wire arc additive manufacturing is a reality, and it is already proving useful. The other form of 3D printing, of course, is not using metal, but in this particular case, concrete or cement. And here's a very nice example of it. A house being built in Germany. And the Germans have taken to this sort of 3D printing of houses, but we are still behind. But I think there are plans in the UK for us also to permit it. It's a question of getting permissions because there are so many rules and requirements. Moving on, if we can use plastic and any old rubbish in order to create structures, and that can be done also by a robot. And this is a robot called, I've forgotten the name of it now, but it's actually being designed and built at the moment. And its purpose will be to turn out structure like you see, the struts of something much bigger. Examples of other robots. Here's another which is manipulating rod-built structures into place. So the technologies of robotics, 3D printing, and other are coming together very nicely. And of course, all you need is time and the ability to send a program to semi-automatic robots, and there you can have a structure as large as you like. That appears to be the case. Here is another example of the printing of rocket cases. And this is wire arc additive printing again. It's only wire, but in fact those rocket cases, this is a rocket case for SpaceX, I think, and that is working very well. So the vision that we started with is a reality in a sense, but only in the far future. We have to bear in mind the difference between semi-autonomous robots and the intelligence that is needed to program them and guide them and give them the decision-making component that they need. This looks as if it might actually happen. Certainly in the 22nd century, I would imagine we would have reached this sort of level, provided, of course, that we're still around. If we have survived, our grandchildren may see something like this, and you know, they may look at these pictures that we see here. This is somebody's view of what the future will look like. Probably in the 22nd century, they would regard this as being rather quaint. And the final vision, habitations in space, cities in space, it may even happen, and our grandchildren perhaps, or their grandchildren, may see it and live in them. Quite possible.